a mixture problem. So any problems where two or more quantities are combined to produce a different quantity, or where a single quantity is separated into two or more different quantities, may be considered to be a mixture problem. So a strength times quantity is equal to the amount. That's what you want to use. So let's take a look at this example. Christine needs a 5% tea tree oil solution to use as a topical treatment for skin rash caused by poison ivy. Christine only has tea tree oil solution that has concentration of 3% and 10%. How many milliliter of the 10% tea tree oil solution should Christine mix with 5 milliliter of 3% tea tree oil solution to create a described 5% tea tree oil solution? So we read the question here. You need to set up a chart, or I like to present this problem using these boxes here. I think it's easier. So every time you see a mixture problem, I suggest you use these boxes, or you can use a chart. I'm showing both of them here. Now, in this here, we have the amount of tea tree oil 3% solution. So here we have, in this container, we have 3%, 10%, and ultimately we want to get 5% out of this when we mix them together. So I'm going to let X equal to the amount of milliliter of 10% solution. So I'm going to write here X, and the amount of 3% is already known, is 5 milliliter. So we have 3% times 5 milliliter plus 10% times X milliliter is equal to, you ultimately want to get 5%. 5% of what? 5% of combination of these two amounts we have, which is 5 milliliter plus X milliliter. So that's why we have 5 plus X. So you get the amount of 3% solution plus the amount of the 5% solution, which should add up to the amount of, ultimately, do I have some error here on this? Let's fix it. So it looks like that we have the amount of 3%. That would be, this is not 3, but this is 10%. So let's fix that. This should be 10%. The label is wrong, 10%. And this is the ultimately going to have 5%. Okay, so here we have it. So it would be 0.03 times 5, which is 3% times 5, plus 10% times X, would be 0.1 times X, equal to 5% times X plus 5. So it would be 0.05 times 5 plus X, or X plus 5. So here would be my equation. 0.03 times 5 would be 0.15. That would be 0.10X. Plus I can distribute these numbers. I could multiply them by 10 if I want to, but I could add them and then just simply solve for X. So the answer would be 2. So the number of milliliter of 10% tea tree oil would be 2 milliliter. So if I want to find the total, would be 5 plus 2, that would be 7 milliliter for the ultimate 5% solution. How many pounds of candy worth $8 per pound should be mixed with 100 pounds of candy worth $4 per pound to get a mixture that can be sold for $7 per pound? So in this case, we want to let X equal to the amount of $8 candy. You can consider the chart in this case. The amount here would be X would be for the $8 candy, and then 100 would be for $4 candy. So together would be 100 plus X. So here we have the pound of candy for $8 would be 100 times 4, which is 400. Then here would be 8X, 7 times 100 plus X. So we write the equation. 400 plus 8X must be equal to 7 times 100 plus X. To solve this for X, by distributing the 7 and isolating x is equal to 300. So 300 pounds of candy worth $8 per pound should be used. You can check the answer. Here's a mixture problem. How much water must be added to 2 liters of 50% antifreeze solution to reduce it to 40% antifreeze? So in this case, I'm going to let x equal to the amount of liters of pure water. And here I showed the illustration of using the box like I showed last time. Here we want to know x would be the amount of the pure water added to, of course, there's no antifreeze in water, pure water, so about 0% antifreeze in x, plus you want to add it to 20 liters of 50% solution. You ultimately get 40% out of that. Remember, the amount is x plus 20 total. So it would be x times 0% plus 20 times 50% is equal to 40% times x plus 20. That would be my equation. You can here solve for x. You get x equal to 5. So 5 liters of water is needed to obtain 40% antifreeze together. It's a mixture problem. How many liters of 40% antifreeze solution must be added to 4 liters of 10% antifreeze solution to produce a 35% antifreeze solution? Different ways you can represent this. I still like this box method here. I'm going to let x equal to the amount of 40%. Amount of 10% given to me as 4 liters. So putting this together would be 4 plus x for 35% solution. So here my formula or equation. 40% times x plus 10% times 4 equals to 35% times 4 plus x. Here I'm going to I can multiply them by a factor of 10 or just deal with the decimal like we have here and solve for x. So x is equal to 20. So that 20 liters of 40% antifreeze solution is needed.